Yo, what is up YouTube? Welcome back to the fourth video in this video series where I'm showing you from start to finish how to build a really cool and really robust multisig wallet application that runs entirely on the Ethereum blockchain. So if you don't know me, my name is Evan McGrain and welcome to Web3 Simplified, where I teach you blockchain development. So if that's something that you're interested in, then I'd really appreciate if you could take the time just to like this video and subscribe, just because it helps this channel out a lot with the YouTube algorithm. So recall in the last video, we continued to develop the multisig wallet smart contract, and we added in the ability to transfer not only Ether, but we also added the ability to transfer ERC20 tokens. So to do that, we used the openzeppelin library and we created our own mock tokens, and then we created a token struct in the smart contract, which allowed us to use our token contract in order to transfer it and send it and withdraw and do all that good stuff. So in this video, we're going to be wrapping up the multisig smart contract, and we're going to be doing one final thing to make it just that bit more robust. And what we're going to be doing is we're going to be using what's called a factory contract to deploy instances of our main multisig wallet contract, so that each user who will eventually log on to our user interface will be able to deploy multiple wallet instances, just like you can in MetaMask, the way you can have multiple different wallets, so that they'll be able to keep funds in different accounts or use different wallets for different purposes and all of that good stuff. So just before we jump into the code, I made a small little PowerPoint just to go over what a factory contract is, for those of you who don't know. So let's just jump into this PowerPoint and we can go through the main characteristics that are involved with factory contracts. Okay, so if we have a smart contract like this, such that it has an address 0x12345, and say this smart contract, you know, is a general smart contract, and we actually want to end up deploying multiple different instances of this smart contract for our application. So an example would be for our multisig, for example. So we could deploy this contract many times where each instance has different parameters. For example, our multisig contract could be deployed where each instance belongs to a different owner. So an owner could eventually log on to some user interface that we develop and create new wallets. And each time they create a new wallet, it deploys a specific unique instance of our multisig wallet contract that we're developing and assigns it to that owner who deployed it. So what is the best way to figure out what owners own what wallet instances? Well, there's one way that we could do this, and we could essentially deploy loads of different contracts like this. And what we could do is we could store all of these different addresses that belong to each of these particular instances in an off-chain database, such as MongoDB. And what we could do is we could deploy, or we could store the addresses and associate each different address with a particular owner and other parameters that we might set as well. So that's one way to do it, but this is sort of more complex and is really only desirable in a more complicated application than this wallet that we're building. So there's another more easier solution to get around this, and that is to use what's called a factory contract. So what a factory contract does is it allows us to deploy instances of another child contract that we define. So in this case, what our main multisig wallet contract would be the child contract, and then we would write another contract which would literally have one function, and that function's purpose is to deploy instances of this main multisig child contract. So pretty much how it works is we write a factory contract and it deploys this multisig child contract and puts it onto the blockchain. And what it does is it effectively stores the address of this multisig contract in the main factory contract. So when we have our factory contract, we deploy instances of the child contract and we store all of the addresses of each instance we deploy in the factory so that we can keep track of all of the different contracts we deployed. So effectively it acts like an off-chain database, but everything is done on-chain. And this is very powerful, and this is the mechanism that we're going to use in order to you know, let users deploy multiple different wallet instances so that they can, you know, store different funds in different wallets. So that on a very high level is what a factory contract is. And now that we have a pretty much high level overview, let's jump into the code where we're going to finish and finally wrap up this smart contract so that we can move on to the next stage of this video series where we can start building out the front end and finishing the application. Okay guys, so now that we have an idea of what factory contracts are and why we want to use them, we'll go and we'll modify the last bit of code that we need to do to wrap up this multisig smart contract. So we're going to use the factory contract or a factory contract here so that we can give different users the option to deploy multiple different instances of this multisig wallet contract. So eventually what will happen is users will be able to log into a user interface and they'll be faced with all of the existing wallets that they have. And they'll also have the option to click a button to create a new wallet and add it to the list. So just think of MetaMask, the way you can log on, or you can just log into MetaMask and you can choose different wallets, you know, for, you know, maybe you want to store different funds in different wallets for different reasons. So we're going to be using the same idea here and we're going to achieve it through this factory contract. So we're going to come down here and I'll just zoom in a little bit if I can. Or why won't it let me zoom in? There we go. So we'll just come down here and what we're going to do is we're going to create a new contract and we're going to call it multisig factory. If I can spell factory correctly. And what we're going to do is we're eventually going to create a function that is going to create an instance of this wallet contract up here each time we call it. But before we do that, we need to do two things. The first thing is we are going to want to create an array to store all of these multisig wallet instances. And the way we do that is we come up here and we grab this name of our original contract and we come down here, the array that we're going to be pushing these instances to is of type multisig contract. So that's why we need to initialize the array or typecast the array as type multisig contract. And then we're just going to call it new or multisig, well, with lowercase, multisig multisig wallet instances. So each time we create an instance with this factory, we're going to append it to this array. And then the next thing that we're going to need is a struct, because what we want to do is we want to be able to figure out a way to store or to identify which user owns what wallets. So if I log on to the application in the end as user A and I'm faced with all my wallets, well, I want to be able to figure out what his wallets are compared to if some other user B logged on, he might have different wallets. So that's what we're going to create this struct for. So we're going to create a struct and we're going to call it user wallets. And for now, it's only going to have one attribute, and that's going to be an address of wallet address, we'll call it. And then what we're going to do is just like we did with the multisig, we're going to create an array of type user wallets so that we can append different wallets to and associate them with different owners. So to do that, we're going to just go user wallets of type array, and we're going to let this equal user wallets. And then one last thing that we need to do is, well, this thing here is just pretty much the exact same as this. So you're saying, well, why are you doing that? Well, if we create this struct of user wallets and make it into an array, then what we can use is we can use a mapping to separate the array of wallets between different wallet owners. So you'll see what I mean here. So if I come down here, I just want to get rid of these two spaces. If I come down here and make a mapping that maps from a user for a wallet owner's address to one of these arrays of user wallets, then we effectively have a way, we'll just call this owner wallets, or wallet owner Yeah, we'll call it owner wallets. Sorry, the naming can get confusing sometimes. So we'll call this owner's wallets. So what this effectively does is this allows us to map or to get the wallets or all of the wallet instances that a particular owner owns. So if you're a bit confused for this, if we were trying to index this, what we would say is owner wallets of message.sender, for example, would be equal to, say, an array of, and then we'd have, say, 0x blah 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 as one wallet and 0x da 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 as the other wallet. And then if we were to come down here and say owner wallets of some other account that's not message.sender, let's just say account 1, then this person would own an array of different wallets like this. So this mapping allows us to associate what owner owns which wallets. So that's all that is. And now that we have these sort of two things set up, we can actually create the function that allows us to deploy instances of our multisig contract. So we'll create a function and we'll call it create new wallet. And we're not going to pass in any parameters, and we'll just let this be public because anyone should be effectively able to do this. And what we're going to do is we're going to create a new instance of this multisig contract up here. And how we do this is we need to grab the name of the multisig, because remember, we're going to be making a new contract of type multisig contract. So we'll grab this and we'll give it a name. We'll say new multisig wallet contract. And to create a new instance of it, we use the new keyword, and then we pass in the thing again, the contract that we want to make an instance of. And then if this if our multisig contract up here had any parameters that needed to be declared in the constructor, we would pass them in these curly brackets. But I don't think mine does. I don't think we declared anything in the constructor. I'll just double check if I can find my constructor. No, we don't have anything in the constructor, so we can just leave this blank. And that will effectively create a new contract, a new multisig contract. And then what we want to do is to be able to keep track of all of the contracts we make, we can just append this instance into this multisig array here. So to do that, we'll say multisig wallet instances dot push, and then we'll push in the new multisig, which is new multisig wallet contract. And I'm just going to save this to see if I made any typos or anything. And no, that all checks out. But we're not done here. We want to do actually two more things in this function. We also want to create a new instance of this user wallet struct, and we're going to want to create an instance of this user wallet struct for the person who calls this function. So it will be message.sender. And then we're also going to append this new wallet instance into that message.sender's array of wallets. So the way we'll do that is we'll create a new instance. So to create a new instance, we just grab the name of the struct. So it's user wallets. I'm just copying it because I always make typos. And we'll make an array for storage. We'll initialize it to storage. I might change it to memory. I can't remember when I did this the first time if it works doing it with memory. It should, but we'll see in a minute. So we'll initialize this a new struct, or a new wallet struct, and we'll call it what will we call it? We'll call it user. I can't call it user wallets. We'll just call it wallets, which is a bad name, but I might rename this when I get the whole thing done. And then what we're going to do is when we have this instance, we want to push, we're going to let this equal the user wallets for message.sender. So I'll grab this and paste this here, and we'll type in message.sender. And I don't need these brackets here. And let's just make sure, let me see. Sorry, this should be owner wallets because that's what we call it. Owner's wallets. Sorry guys, I just had a little typo. I did need to typecast as an array because remember we're going to be pushing these new multisig instances into the array of user wallets for message.sender. So I'll explain just when I type this next line exactly what this is all about. So now that we have created and we've initialized this new wallet struct, we actually want to, or now that we've allocated memory for this new wallet struct, we want to actually create an instance of it. So to do that, remember what we did, just like we did up in the actual wallet contract, we can just take this name, so new wallet. And what we're going to do is we're going to push in an instance of this new wallet struct. So to make an instance, we type in user wallet, and then in here we pass in all of the attributes we want to define. So we only have one attribute that we need to initialize, which is the new MultisigWallet contract instance. And you'll notice here, if I save this, I get an error. And why is that? Because we cannot convert our contract multisig into an address. So to get around that, we can just typecast this to an address. And then this will push in the address of the multisig wallet contract into our array for message.sender. So this should be okay now. And that was a few lines without me explaining. So I'm going to sort of explain what this is. So what we want to do is we want to keep track effectively of what wallet owners owns or has access to which multisig contract instances. And the way we do that is I create a struct which has the wallet address, which is going to be the address of the multisig contract, and then I store an array of these user wallets. And then through a mapping, I'm able to map an address, which will be an address of some wallet owner, to this array of multisig contract instances. And using this mapping, what it will allow me to do is it will allow me to separate which owner that we pass into this mapping owns what wallets. So this user wallet array here is going to have a list of all of the different multisig contract addresses for a particular user. So just like I was saying, if I passed in message.sender, this would return an array of wallets for message.sender that he has access to. However, if I passed in a different account that wasn't message.sender, then this would return a different array of all of the wallet owners that particular owner has access to. So that's what we're doing here, is we're initializing this or we're allocating memory for this struct, and we're letting it equal to the we're letting this array equal to message.sender because he calls the create new wallet function, and then we're just pushing in an instance of this new multisig wallet contract, because obviously if I call this function and I'm the person creating a new wallet, then I effectively have access to that wallet, so we need to push it into the array. So that's all that's doing, and we only need to type 2 more functions now. But before we do, I'm actually just going to make a quick event. So we want to make an event here, so we'll call it event, and we'll call it wallet created, and we'll pass in as we'll say address created by, and then we'll pass in a uint block.timestamp, time of transaction, and we'll also pass in address, and we'll pass in the multisig itself, address, wallet or new wallet address, contract address, we'll say, just to be more transparent. And then down here, what we can do is we can emit this event. So we'll emit the wallet created, and we'll pass in message.sender. We'll pass in a new multisig wallet contract because that's going to be the address, and then we'll just pass in block.timestamp, like so. And that is the create wallet function. Sorry, I forgot my thingy here. Oh, sorry, I always do that. uint time of transaction, like so. And then what do I have here? New multisig wallet contract, invalid conversion. Okay, so we have to say address. And that should be everything now. And boom. So there's only 2 more functions that we need to add now. And we need to think about this a bit, because if we come back up here into our wallet contract, we have the ability for owners to, or for the wallet owners to add new members into the array, or into the wallet owners array. And we also have the ability for them to delete new members from the array. So we need to add this or mimic this functionality in our wallet contract. So we need to be able to somehow if we initialize initialize an array of wallet addresses that a particular owner owns, then we need to add functionality that's going to delete or add new wallet addresses to that array if the users end up calling the add and remove owner functions in this contract up here. So the way we're going to do that is we're just going to make two functions very similar called add and remove. So the first function is just going to be called add new wallet instance to we'll just call it that for the moment, and we're going to make this be public. And what we're going to do is in here we're going to just copy this. We're going to make a new an instance of this new user wallet struct, and as arguments we're going to pass in the address of the owner that we want to add the wallet to, and we're going to pass in the address of the wallet or contract instance that we want to add to their array of addresses. So we'll just pass in wallet address. So what we're going to do is we're going to initialize memory to this this user wallet struct, and then what we're going to do is we're going to add into this struct the wallet address for a particular owner. So to add a particular wallet contract, or to add a wallet instance to a particular owner's array of addresses, what we need to do is we will just call this new wallet struct array of structs, and we'll push in this wallet address that we pass in. And just note that this should be equal to owner actually, because we are going to pass in the owner that we want to append this new wallet to. So the way we do that is just like up here, we'll call this new wallet, and we'll say dot push, and then we'll push in the user wallet struct of this wallet address that we are passing into the function. So if we save this, hopefully this won't give any errors, and boom, that's all we need to do to add a new wallet instance to an owner's array of wallets. And then likewise, we're going to want to create a function that does the opposite. So we'll say remove, and I'm just going to copy this. So we'll remove new wallet instance. Again, we're going to pass in the address of the owner, or the wallet owner that we want to remove, and the wallet instance that we want to remove from their collection of owned wallets. And we'll call this public. And in here, we're literally just going to do the exact same thing that we did here. We're going to use this algorithm here. But what we need to do first is we need to create an instance of this array. So I'll stop copying and pasting because it's easier for people to follow along. So we'll say user wallets, and we'll say storage, and we'll call it new wallet, and we'll just initialize it to owner wallets again of the account that we pass in. And then what we want to do is we want to set the bool like we always do, called has been found equals false, false, F-A-L-S-E. And then we want to also create a uint wallet index, because remember, when we're trying to remove something, we need to find at what index the thing is we're trying to remove. So we'll call this wallet index, and then we just create our for loop. So we'll say for uint of I equals 0. I is less than the wallet, the new wallet dot length, and then we'll say I plus plus because we want to increment our looping variable. And then in here we say if new wallets of I dot wallet address, because remember, wallet address is the attribute that we have. And just to make this a bit better, I'm going to say underscore wallet address, just so we don't confuse ourselves, and underscore owner. And I forgot to typecast these as well. And then we're going to say if the wallet address at that index in our array is equal to the owner, or to the account that we pass in, we'll say the owner that we pass in, then we know that that owner owns that wallet, so we want to remove it. So we'll say has been found equals true, and then we can break out of this. And also we need to set the wallet index equals I, and then we can break out of this, and then outside of this this for loop, we can say and I want to say wallet index, and we want to increment wallet index in the case where it hasn't found it. Actually, no, we don't, because we're just going to set it equal to I anyway. So outside of this for loop, what we can do then is we can just, as normal, require that has been found is equal to true, and then we'll say the owner does not own the wallet specified. So that will be our error message. So if we pass in some owner and then we pass in a wallet address that they don't own, then we can't remove it, obviously. So that's what this require here for is. And then just like normal, once we have the index and we have the address and we've met this requirement statement, then we can just say new wallet of wallet index, we'll say, is equal to new wallet of new wallet dot length -1, and then we just simply pop off the last element, because effectively what we're doing here is we're getting the new wallet and we're going to the index of the address we want to remove, we're putting it at the end of the array, and then we can just call .pop to get rid of the address we don't want. So we will now call new wallet .pop, and boom, that should be it. And no errors. I do have a few errors. Okay, let's see. This one here, account, I should be passing in owner, and here it should be underscore owner as well, and or sorry, this should be wallet address, so we say equal to wallet address, and then this should be okay. Okay, what's wrong here? New wallet. Did you mean new wallet? I did. Wallet, new wallet. There we go. And I have a few more errors now. Okay, multisig, not effectively. Okay, so I forgot a bracket there, or an array there, and boom. So this should compile now, and boom, that is everything that we need to do in this multisig contract. There's one other function that I'll write, which is just a getter function. So we'll write function get user wallets, or get owner wallets rather. It doesn't matter, I keep get owner wallets, and this is just going to return public, or this is going to just be public view returns, and here we'll return user wallets of memory, and then we want to just return user wallets of owner. And then we'll just pass in owner up here, so address owner, and then this will return the user wallets for a given owner. So okay, I have a mistake here. Actually return the name of the array, which I think is just user wallet. Well, it mightn't be user wallets, but that's what we have to do. So okay, we get the name of this array. It's called owner wallets. Like so, and boom. So that is this contract complete. I know it's a bit complex, and I have been moving quicker because a lot of the sort of stuff like this I was explaining when I was in the last few parts, so I am assuming you're acquiring knowledge each time. And this is sort of more complex. Like when I was writing this, I actually didn't write this multisig factory until I had my UI built, so it was easier for me to test this. Like we're not going to be able to test this in Remix, unfortunately, but we will be testing it in the next episode. But there's two more things that we need to do in this factory, or in this original contract, is we need to link this add wallet owner function and this remove wallet owner function to these two add and remove wallet owner functions in our factory contract. And there is a way that we can do that. So what we're going to do is when we call the add owner function in this in the main multisig contract, for example, what we want to do is after all of this is said and done, we're going to want to call the add owner function in the factory contract so that we can append the address of this contract to the array in the factory. So it sounds a bit complex, but you'll see what I mean in a minute. So what we want to do is in the constructor to do this, what I'm going to do is I'm actually going to make a global array called address, and we're going to call this contract wallet. We're going to call this multisig instance, like so. And what we're going to do is we're going to come into the constructor wherever the constructor is. And what we're going to say is we're going to say that multisig instance is equal to address this, which will just return we'll just set multisig instance equal to the contract address, which is what we want. And then what we're going to do is we're going to create 3 different functions. So I'm going to actually create them above the add wallet owners, and we're going to create 2 different functions. We're going to create a function called call add wallet owner from the multisig contract, and then we're going to create another function called call remove wallet owner from the multisig factory contract. Okay, so to do this, effectively what we're going to do is we're just going to simply create a function, and we're going to say call add owner. And what this is going to take in is it's going to take in the account. So it's going to take in an address of the account, or we'll just say the owner that we want to add the wallet, the new multisig instance to his addresses. And then it's going to take in the actual contract instance that we want to add to his addresses itself. So we'll pass in address, contract, or multisig instance, we'll call it. Like so. Oh, if I can spell INSTANCE, like so. We're going to have this as private because the only time we're going to call this function is within the add owners function. And then we're just in here. What we're going to do is we need to initialize our factory contract. So if we initialize the factory contract, then we will effectively be able to access its functions so that we can call them. So to do that, I just want to remember what I called it. I called it multisig. I called it multisig. This should be sig. Like so. Yeah, okay. So I called it multisig factory. So if we come back up here to the, sorry, my remix is bugging it a bit. So we want to initialize a instance of this factory contract. So we'll say multisig factory, and then we'll just call it factory. Is equal to new multisig factory, and then we want to initialize the factory for a given instance. So we're going to pass in this where is it, the address that we initialized in the constructor, so multisig instance. So we'll come up here to my function wherever I put it, and we'll say multisig instance. And I'm noticing that this is a bit of confusing now, so I'm actually going to call this multisig contract instance, like so. Yeah, so that's fine. And then what we want to do is, now that we have an instance of this factory contract, we want to call the add owner function from this factory. So we're going to call factory.add owner, or it's called add new wallet instance, I think. And we want to pass in this owner that we want to add an address to. We want to add a contract address to this owner's array of addresses, and then we'll pass in the multisig contract instance that we want to add. And boom, this should be okay. I have a typo somewhere. Like so. Now that should go away, and boom. And that is that. So we want to duplicate this function now and do the exact same thing for the remove wallet owner. So we're going to create a function called remove wallet owner, and again we're going to pass in the address of the owner that we want to remove the wallet for, and the address of the multisig contract instance that we actually want to remove. And this is going to be private, private. And then we want to do the exact same thing where we get multisig factory, and we just call it factory, and we let this equal to multisig factory of the contract instance that we want to initialize. Because if we have loads of different like wallet instances or multisig wallet contract instances, then we need to distinguish which one we want to actually initialize. So to do that, we pass in the address of that we initialize in the constructor. So multisig contract instance, or multisig, not that one, the other one, multisig instance, like so. And then when we do that, we can simply just call factory.remove owner, remove wallet instance, and then we pass in the owner that we want to remove the wallet instance for, and then multisig contract instance. So this should be okay now, and it is. And now that we have these 2 functions, we can call these 2 functions in the add wallet owners. So what we can do now is we can come into the add wallet owners, and then just after we emit this event, what we can do is we'll just call this remove wallet or this add wallet owner function. So we'll call add owner, and the address or the owner that we're going to pass in is this owner that we have here. So owner. And then the contract instance that we're going to pass in is, I actually think I shouldn't initialize it in the constructor. I think I should rather initialize it as in a function. So yeah, sorry about that. I'm not going to want to initialize this up here because it's just going to be the same every time that we call it. So what I'm instead going to want to do is we're going to come here and make a function called set multisig. Set. We're going to make a function. I'll explain this now once I can spell it. Set multisig contract address, and this is going to take in the address of the multisig that we want to initialize. So I'll just call it wallet address. And this is going to be private also. And what we're going to say is we're going to let the multisig contract instance, if I still have that, do I? We'll let the multisig instance, multisig wallet instance equals wallet address. So this is effectively, we can call this function to initialize any contract or any version of the multisig instance that we want. So I am going to actually have this as a global var up here. So this is just going to be an address multisig instance like so, and that should get rid of any errors. Oh yeah, well, this one. So now that we have that, is this will effectively allow us to pick which multisig contract that we've deployed with the factory that we want to initialize, or so that we can actually remove it from the wallet owners. So what we can do is in this is going to take in two more things now. It's going to take in the actual wallet address that's going to be stored here. So we'll say wallet address, and then, or wallet address, sorry. And then it's going to take in the actual multisig contract instance that we want to, or multisig address that we want to delete. So I'm just going to call it address, or underscore address. So bear with me for a minute. I'll explain this more when I type it all out. So what we want to do is we want to, first of all, set the multisig instance that we want to access. So we'll say set multisig contract address, and here we're going to pass in the wallet address that we add into as a parameter into this function, and then we want to call add owner so the add owner takes in the multisig contract. We want to call add owner for the address itself. And then this will effectively, after it adds the wallet owner, what this will do is that it will call this add owner function from the multisig contract here. And then effectively what it will do is will append that wallet contract to that owner's array of addresses so that he'll always be able to log into it. And if we save that, I have an error up here, and that's because this should be called multisig instance, because we want to make sure that this address here is the exact same as the address that we're initializing here. So sorry, I should call this not wallet instance. I should just call it multisig instance. And then just to make sure these are spelled correctly, I'm going to swap them out here, and we will swap it out here like this as well. And boom, that's going to compile now. So now we want to do the exact same thing in the remove wallet owners function. So down here, what we're going to do is we're going to say set contract address to the wallet address. Oh yeah, we have to actually come in here and add those parameters. So we'll say address, wallet address, and then just address, which will be the address of the wallet that we want to move. So this is always going to be the contract instance address, and this is going to be the address of the wallet that we want to remove. So we'll set wallet address here, and then we'll just call remove owner. Did I not call remove owner? Call add owner. Sorry, I want to call, this should be call remove owner. Call remove owner, like so. And then this one down here, we can just call remove owner, and then we'll pass in the account of the owner, or the address of the owner that we want to remove the wallet for, and then the actual address itself. So that is this completely complete. I know that was quite a difficult. There wasn't too much coding, but actual wrapping your head around the code it can be a bit difficult in this. And even I was struggling a little bit, because it's so much easier to do this when you have a bit of your UI already built and you know how you're going to test it. But we are not going to be able to test this now, as we'll see. So doing this at the very start is not the way that I would go about it, but this is just the most optimized way for me to do it in terms of making a course. So you can see it's in a more modular format where we're doing everything in sections. So contract, testing, UI, and all of that in different sections. So now that we've done this, let's see if we can actually deploy this. So I'm going to come in here and we'll get the multisig factory. Then you'll notice we have, oh sorry, that's the wrong contract. I didn't mean to deploy the actual multisig. I meant to deploy the factory. So if we come along and deploy this now, you'll see it deploys, no worries. And we have all these options here. Now, we're never going to be calling functions directly from the multisig. The only function we're going to be calling directly is this create new wallet. So ideally, I would probably change these two here to external, so that we can call them from the actual contract here. But for now, I'm going to change it until we actually do the testing. So let's just create a new wallet here. And that was successful. And then let's grab message.sender here and pass them into get wallet owners. And boom, you can see that we have the address of the wallet that we just after deployed for message.sender. And you can see if I come in here and grab, say, a new account like so, and I pass him in here, and I get wallet address, and you see he has no wallet addresses because we didn't create a multisig contract for that owner yet. So let's see if we can actually delete addresses. So we'll come back up here and just get the wallet owners again. Oh, sorry, I have to paste them in. There we go. So we paste this guy in, and boom, we have the address back. So let's see now if we can yeah, we can try and see if we can remove this wallet. So what we'll do is we'll pass in this account here, and then we'll pass in this, and we'll paste it, and we'll remove the owner. That was successful. And if we get wallet owners again, then it goes away. So yeah, we can do minimal testing in here, and then I can pass in maybe this guy here, and we can pass them in here, and then we can grab where is that address gone? There we go. So let's grab this address here, and let's try and add it. Add user wallet, and then if we get user wallets, then boom, that wallet address comes back in, which means he has access to it. So that's the maximum amount of testing that we're able to do with this. So what we're going to do in the next episode is, well, first of all, congratulations, you've finished the multisig smart contract part of this course. So this effectively here is the entire contract. It's quite a big contract, and congratulations if you've made it this far. So what we're going to do in the next episode is we're going to take this contract into VS Code. We're going to initialize truffle, we're going to initialize npm, and we're going to start doing tests from the command line to play around with all of this and be able to test it in a more robust way to see if the multisig factory contract aspect of the whole thing works the way we expect it to. So yeah, that's what we're going to be doing. We're going to be doing that test, and then boom, we're going to be straight on to developing the user interface. So I hope you guys really enjoyed this video. This one was a tough one. It was the hardest one out of all of the contracts, so our contract videos so far. So yeah, I will see you guys in the next video. I should have it up sometime during this week. So I will see you next time, guys.